welcome to my YouTube channel. In this video, we are going to discuss about importance of data pre-processing and what are the different techniques that we are using in data pre-processing. Okay, so we will be starting a new channel and we will be discussing each and every point in detail. So the question is why we need data pre-processing. Okay, so most of us are already have done a lot of models from created models using different data sets, maybe probably from the Kaggle or some other sources, and we may be getting like high accuracy, maybe 95% of accuracy or 98% of accuracy with those data set. But most of the data set that is available in Kaggle or some other places are mostly is a clean data set. Okay, there may be some kind of a issues are there, but still like it contain, most of them contain like a clean data set. But in a real world scenario, the data is actually missing. I mean, data is actually messy. Okay, so it's due to different reasons. It may be the data may be missing lot of values, or it containing inconsistencies, or it containing irrelevant informations. So the missing values may occur with different reasons. One is definitely human errors. So data may be collected by the human, and definitely like there is some percentage of human errors will be there with all the data set. And maybe we are collecting data through sensors, so there may be like sensor issues will be there. Sensor may not be working, or there may be some power issues, then we may be missing some data in between. Okay, then incomplete records. Okay, so this may be the reasons for missing values, and definitely there is some inconsistency will be there. So that is also kind of a human errors. Okay, maybe different data format. Okay, consider like if we have a data set which contain the date of birth. Okay, so in that field it may containing in the date of birth or date may be containing a different format. In one feature or one record may be containing like M1DDYY, and in another feature maybe it's contained like M1DDYYY, something like that. Okay, so we need to handle all those different format, and definitely there will be some typing mistake also will be there. So these kind of inconsistencies actually bring huge impact to our model. Okay, so the algorithm actually failed to, so in this scenario algorithm actually failed to understand a unique pattern. Okay, and the convergence will be taking time, or it may be failed to converge. Okay, then the third point is irrelevant information. Okay, the data set may be containing a lot of duplicate data that also may confuse the model or algorithm. Okay, and maybe it contain like lot of features which are not significant to the target variable. Okay, consider an example like house price prediction example. Consider that example, we have a set of features, or we can say that set of independent variables on we need to predict the price of the house. Okay, so consider if the features are like the square feet, number of rooms or number of bathrooms, and all those things are there as a feature, and we know that all those will be contributing to the target variable or contributing to the price of the house. Okay, and considering like the gender. Okay, if the data set is also containing gender or the color of the paint or all those things. Okay, so in that case this gender may not be contributing to the price of the house, right? So we need to identify those features which are not contributing to the target variable. Then we need to remove those variables or those features. Okay, so that is also impact our accuracy. Now actually what algorithms are expecting some clean data. Okay, so that is another thing that we need to take care. So there may be like features, data set may containing issues like scaling issues, and it may be contained in the categorical data. So the scaling issues means consider if we have all those things we can discuss in there definitely there will be a detailed discussion on all those features and how to handle this, but this is a high level overview. Okay, so the scaling issues means consider if you have like a 3 features. Okay, so one feature may be varying between 0 to 10,000, and another feature may be varying between 0 to 100, and another feature, the third feature may be varying between 0 to 50. Okay, so the scale is actually different. Okay, so if the scale is different, so it will actually, model will take some time to convert converge it. Okay, so it is actually costly, and we may have to provide a lot of data for that. Okay, so we may need to do some kind of a scaling techniques like min-max scaling or standardization scaling mechanism, scalar mechanisms, all those things we need to apply, so that like these features will be reduced to in a common scaling, maybe between 0 to 1. Okay, so that is mean by the scaling issues. Then we have the categorical data. So if we have a lot of categorical data, the algorithm is actually expecting integers or the floating point, not categorical data. Okay, so we may have to convert those categorical data, or we have to handle those categorical data. So that is the one of the major thing. Okay, so what happen if we like if you do like if we fail to do the data processing? Okay, without proper processing, it will definitely reduce the accuracy, and our data set may have lot of noises, and this will eventually lead into the overfitting, and definitely it is inefficiency, because it will take a lot of time to converge, and it will take maybe hours to training and all those things. So these are the major causes that will impact without proper pre-processing. So there are few processing techniques, data processing techniques. That is, one is data cleaning. So that in data cleaning area, it will majorly we discuss about the handling missing values, identify the outliers, and dictating and correcting the inconsistent data. Okay, then data integration. Okay, so we may have to merge data from multiple sources. Okay, then we need to handle the duplicates. Okay, then the third point is data transformation. So in data transformation, we will have a scaling features that we discussed. Then we have to encode the categorical data, and we have to do the feature engineering. Okay, then the fourth point is dimensionality reduction. So there are a few dimensional reduction techniques are there. One is forward selection, backward elimination, PCA, that is principal components analysis, and singular value decomposition. These are the few dimensional reduction techniques. Okay, and maybe like some other techniques like sampling. So sampling means if we have a lot of data, or our data set is too big, we may have to pick few data from there to train the model. Okay, then we need to handle the imbalanced data. Okay, so imbalanced data, one of the example for imbalanced data is consider we have a data set, a classification data set. We need to classify dog and cats. Okay, consider it is a image classification, and we have the data set with we need to classify it to dog and the cats. So maybe the dog data may contain like 10,000 records. Okay, maybe in the training data set, the cat data set is maybe very less. It may containing only the 100. Okay, so the dog containing the 10,000 training data, and the cat data set contains only the 100 number of data set. Then this is actually imbalanced data. So we may have to do some imbalanced techniques to handle this imbalanced data. We have to do some techniques to handle the imbalanced data. So these are the few data pre-processing techniques. Okay. Yeah, definitely, like in our coming videos, we will be detail out all those things, all those data pre-processing techniques. Okay, yeah, so the purpose of this video is to give a high level overview of the use of data pre-processing and the major techniques of data pre-processing. Okay, so that is all about in this video. Please do like and subscribe, so definitely we can see with more details. Okay, bye bye.